plow through the last section here and get everyone to lunch. So, all right, now that we've trashed ORMs thoroughly, what's the future? What do? We have the two exoplanets happily orbiting the same sun. I don't think we would really be that close to each other. So, one thing that's, despite the amount of trashing that I've done on ORMs here, one thing I do want to get across is ORMs intrinsically aren't evil. There's a lot of categorical statements you will hear in the database community about the problem is ORMs. And the problem is not ORMs per se, any more than it is, the C language per se. They're invaluable for their core operation, which is object persistence. That's what they're good at. They do it very well. They've had decades now to get that problem pretty much under control. And no one is going back to the old school of application interfacing. It's not going to happen. So ORMs are a reality that we're going to have to, we will have to approach and we will have to come up with strategies for. Most of the problems come from this hammer-nail attitude of we've got an ORM, that's how we get our database. If we want to do a join, we use the ORM. If we want to do a mass update, we use the ORM. Everything has to go through the ORM. It has to go through the ORM using the ORM's native APIs. And culturally, ORMs have been pitched as a way not to learn SQL. One thing that ORMs can be legitimately accused of is they've created this world in which where it's bad. If you have to learn SQL, it's a failure on the part of the technology, and that's an attitude we have to fight. So one action is, well, why don't we just do a better ORM already, right? An ORM that doesn't have all these problems. That is not the answer. Okay, we have to stop chasing after this illusionary ORM that's off in the sunset, like a mirage beckoning us. ORMs have been around since the early 1990s at the latest. I'm sure there are ORMs you can find even earlier than that. If we could fix it with better technology, we would have by now. The ORM space is very thoroughly explored. If there were an easy technology fix to all these problems, we would have nailed it. And virtually all production ORMs have a way of solving these problems by now, even if it means stepping outside the ORM itself and going to the raw SQL. Because the people who are actually building these ORMs, by and large, have hit these problems. These problems are not new to the ORM implementers. But we're not taking advantage of them when we build our applications. Everything that we've talked about can be fixed here. But there are different kinds of fixes for different layers of the problem. There are some technology fixes, there are a lot of educational fixes, and there are management level fixes that we need to apply. So, better application architectures. This is great if you happen to be in a place of being able to architect an application from the start. Not always the case. Don't have the primary interface be the ORM. Now that seems like just contrary to everything that an ORM is about, but it's actually, the problem is, ORMs are a relatively low-level technology. From the point of the application, they're the lowest level in the database access stack. They're like the stream when you're going after a file. They're very low, they're a very primitive operation, and yet, they're the only API that we're exposing. So, it's a low-level component. So push the interface up to the next layer, and have the ORM be one of the components that technology that interface accesses. And it gives you, basically, this is giving you a rub to sweep the SQL under. If you need to do custom SQL, it gives you a place to put it. It's that's parallel to the ORM, that's not, excuse me, that's parallel to the ORM, and that is not directly exposed to the application program. We can do some friendlier database design. One thing you can do is turn the database into the application server. Postgres is uniquely well suited for this particular solution. Have the API to the database be through stored procedures rather than direct table access. That's one possibility. Create views. Views are very nice. Generally interact with ORMs pretty well if you can get around the primary key requirement problem, which is a little bit nasty, but you can figure out ways. So, for example, you can encapsulate big joins inside of views rather than expect the application programmer to know them directly. This is a very strong PostgreSQL point, which is use a familiar language for stored procedure implementation. It doesn't have to be PL/PG/SQL. There's PL Python U, there's PL Perl, there's PL Java, there's all these things. A lot of the resistance simply comes from the fact that, from a procedural point of view, they don't know these languages, and having 12 pages of PL/PG/SQL thrown at the application programmer is pretty intimidating. So, you can wrap up the SQL in this sugarcoating of either Python or Perl. Working with a client long enough, it finally came down to, we just don't want the procedural part in PL/PG/SQL because we don't know that stuff. Can you implement the sort of procedure in Perl? It's like, well, thank goodness you're on Postgres. So, and a lot of background operations can be pushed outside of, like batch loading, daily update processes. You can push these outside of the ORM because they're not core to the application, and achieve significant speed ups that way because they don't have to go through the ORM layer. And there's a lot more receptiveness to using raw SQL at this layer. So a few just basic truths. Web developers tend to be really focused on the front end OLTP, and they view everything through that lens. What can I do to do the online transaction processing? That's what the web application is to them. And from that point of view, what they need is an object store, and so everything's viewed through that object store lens, and the ORM is the obvious solution. So one thing that we can do as database people is make them aware of the issues involving data warehousing and analysis architecture, because this is where the ORMs generally bomb, is when you're trying to do these operations that SQL was originally designed to support. I mean, SQL was not originally intended as I'm going to store tiny little data objects in a database kind of language. It does it okay, but select was intended with a much bigger axe than just writing single rows. It was intended for these big data warehouses. So the more we can explain why these exist, the more receptive the application programmers will be. It doesn't hurt to point out that people who know SQL are in demand and well compensated to application programmers. And it's a career development opportunity. So yes, there's things we can teach. This is one of the reasons, and it drives me nuts, is that the whole way we teach SQL to application programmers is wrong. We teach it like a command language. It's like connect and type a select and see things come back. Well, that's great, but that is showing a very limited aspect of what SQL is about. SQL is sort of the tip of the whole relational model iceberg, and approaching it from this is kind of like the hello world way of teaching a programming language. It's like you don't really learn the programming language, you just learn a tiny bit of its syntax. So teach the relational model instead. This is because the select and SQL and its friends make a whole lot more sense if you're thinking about the data from the point of view of the relational model, rather than this is just a place for my stuff. And remember, programmers generally love efficiency. They want to do things, they want to make the best use of the resources they're given, mostly their time, and that is one of the reasons ORMs are so popular, is it saves them a lot of time. But this is a golden opportunity to explain to them how to deliver this kind of stuff more efficiently. For example, one of the reasons that ORMs tend to fall down and direct SQL is better is that we want to reduce the data as much as possible on the server rather than ship it across the wire and analyze it. And virtually any competent programmer will understand that that's a real problem. And also, they need to understand that databases are a discipline, that just like object-oriented programming is a discipline, systems engineering and network engineering are disciplines. It's not a priesthood. This is not some magical thing you have to learn. It's just a technology. So, more education fixes. This is a problem I've run into in a lot of shops. Is developers are using a system other than production database systems. Like they'll use SQLite for production, for development, and then deploy on Postgres because they think somehow they can't run Postgres on their laptops. I mean, Postgres runs great on a laptop, but the problem here. This has two problems. One is it's giving them a bad idea of what a relational database is capable of in terms of functionality. If they had that functionality sitting right in front of them, they take more advantage of it. Also, it drives home this idea that the database agnosticism of ORMs is the most important feature in the entire world because otherwise they can't easily switch from production to development. So move development on to use the production database during development. Teach them to tail the logs. Even if they don't fully understand every SQL statement, there are a lot of problems that just appear out of nowhere if you are, or their sources appear out of nowhere if you are looking at what the database activity really is. I mean, it's just profiling. And if you start seeing these 1,000 item in clauses, you'll know that your application's broken. You will have to overcome the visceral dislike of looking at SQL, but this is important. It's a career development opportunity. And again, I'm hammering on this. Teach the relational model. Teach why the data is structured this way, not just, oh, you issue a select to get the data. Okay, moving up the organizational stack here. There's, you know, most technology things these days, especially in startups, happen bottom up, but top down has its role. No application is pure OLTP. This is the big lie of the web framework, is that everything is designed to support the OLTP of the web front end, but it's not, you always have to do management reports. You always have to do data warehousing. This will come up in any real business that's successful. There is no business in the world that's pure 100% non-OLTP. And if you do this, this costs real money. You have to pay the consultant to come in and fix the problem. You have to buy a bigger machine to support the transaction load. And this stuff isn't free. And especially now that so many companies are running on web hosting or on shared hosting environments where they're paying, where the meter is running every time it does one of these. It's not just a matter of buying a bigger box. Then you can point to the spikes in actual dollar cost. You know, hardware, virtual server time, and you know, remember those expensive SQL consultants?